Going. What's new? No? Nothing? So, homework was done last night. I know there's some type of malfunctioning, something or other on one of the questions, even if you've got the right answer. I don't know what that is, honestly. I looked it up. I can't figure it out. So if there's a problem, let me know. I mean, if you think you didn't get credit for your answer there, let me know. But I think everybody got credited if you got it right. You didn't get credited if you got it wrong. The correct answer is 2 degrees of freedom. So that is that's what I can tell you quickly. I can't tell you why that problem shows up. Let's see, what else? We left off, there was a quiz that was supposed to be enabled, and of course, this time I didn't see the enable quiz button. Really? That's interesting. I'm having an issue getting my laptop to display. It was working and now it's not. So, this is just typical for today. There. Is it working? No, it's not working. My screen thinks it's working. This is hilarious, let me tell you. Try this. You see anything now? Oh, there, of course. There's the screen I can't see. Why not? Okay, let's do this. Well, son of a gun. All right. I will do it in 2 screens, and I will get the arrangement correct here. Give me a second. This will all work out, hopefully. Oh my God. All right, forget it. Okay, so it looks like I'm stopping the stream. Anything else? Welcome back. You can see this? Oh my goodness. All right, that's awfully big. I want to talk about the quiz. So yes, the quiz 9, I had mistakenly clicked the option to let it be open until April 13th. Displaying the day I told it to start displaying last class at 1:30. Come to find out this weekend, I didn't click the make the link available. So it was displaying a link that was not available. Does that make sense to you? Anyway, it's up there. It's up till Friday, but I'm going to tell you about it right now. Does that sound good? How many of you tried this up till now? Awesome. How many of you watched the videos? What'd you think? Ryan. No, Ryan, go ahead. It's okay. I can take a hint, guys. It's okay.
I was just saying your voice is very soothing.
That's the first time that's ever been said. My voice strikes fear into my little toddler son whenever he acts up. Like getting into dad voice. And I get that with technology now. It's like default now. It's like instinctual. I don't know. So let's talk about this. What is residual maximum likelihood?
Basing your model off of what the residuals in your covariance matrix should look like.
Close. You got residual part right. Covariance part right. Residual maximum likelihood is a version of maximum likelihood that gives you unbiased estimates of your variance components. You can think of it as when you took basic statistics and you were learning about standard deviation. There was the n and the n-1 formula. Maximum likelihood is the divide by n for standard deviation, whereas REML is the divide by n-1, although it's not technically n-1. It's n minus the number of fixed effects minus 1. And it's still, that's not entirely correct. It depends on which variance component, but just by analogy, right? So this whole time I was telling you how awesome Lavon was because you can directly model all of your effects. And maybe you believe me and maybe you were skeptical because that homework was pretty hard, right? Right? It's about to get worse. But the good news is the lecture I just recorded today, what you should take from it, again, I do say a lot of blah, 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 model, 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 blah, blah, blah. But I try to summarize. I even say that in there, blah, 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 blah. Actually, if someone wants, I don't know if anyone does anyone have my phone number and can text me? You'll hear my ringtone. It's my son's voice going, blah, blah, blah. I don't think I can text myself and have that happen. Anyway, so yeah, it's if any of you finds me on Hangouts on Google, just use John Templin at Gmail. If you send me a Hangouts, I think it'll say that. Anyway, yeah, I say this in the video, and mainly I'm trying to tell you all this complicated stuff is way better than the stuff you could have learned if you were taking the old...
Blah, blah.
Thank you. Thank you, Jacinta. Thank you. I appreciate it. So you hear that? And I leave the ringer on now. I was in a meeting with the dean and the other department chairs, and the dean was talking, and it went blah, blah, blah. And someone's like, you don't turn your ringtone off? I'm like, oh, it's a metaphor. Because I tell my son that's what daddy does at work all day. Blah, blah, blah. And anyway, yes, blah, blah, blah. So I do say that, blah, blah, blah in the video. But then I go, everything we're doing with these complicated things gives you the same numbers as you could get out of the classic way of doing it, but it gives you so much more power, so much more cool things that you can do with it. Power as in knowledge, power as in adaptability to what might come next, power as in creating a model that fits your data right rather than squeezing your data into a model. Right? I think that's where we're at. But yes, it comes at a price, and that price is heavy on interactions. So this is the part why the lecture and the upcoming homework is why I've been drilling interactions from day one in this class. Because sometimes to do multivariate models, you have to know them. First of all, you need to know them anyway to describe linear models. They're really important. Some of the coolest results in science depend on interactions, right? Actually, not just cool, the most accurate results sometimes depend on interactions. But second, because some of the more complicated analyses really ratchet up the number of interactions you need. So that's us, but residual maximum likelihood variance components are unbiased. Yes?
Just go back to that word residual. Do you mean error?
Yes. Yes, and so what happens in the likelihood function is that there's a small little change in what we do. And so I taught you maximum likelihood. I said in goes your data, in goes the parameters, out comes the height, right? Residual maximum likelihood effectively swaps out the data part for the residual. So it says, and how do you know what the residual is? Well, you don't, really. So it gets really complicated quick, but basically it's saying it's basing its likelihood on that of the residuals, which is why I was pointing out, Kevin, you were on the right track for what we were talking about there. So with that, because it's doing that likelihood on the residuals, it's giving you the unbiased version of the model because all those fixed effects are the n minus one, the minus one part that you'd have to take off to make it work. So why residual maximum likelihood is important is twofold. Number one, if you have the same data, when you watch the next week's lecture, you'll hear more about this. But it is going to give you the one-to-one correspondence of what we did in Lavon, in mixed model software. Lavon doesn't have REML, and what you would do in LM. Right now, if you go back to your early homework and you try doing the same model in Lavon that you did in LM, just a univariate linear model, you're going to find different numbers for the residual variance itself. And because there's different numbers for the residual variance, then there's going to be different numbers for the standard errors of each of your beta weights. And you're like, okay, how different? Well, again, not much different depending on sample size. You got a huge sample, not going to look that much different, but there's a reason why they're different, right? One is using, the old version is using which the equivalent of REML, and the new version is using ML, which is not likely for it. So unbiased is important. It helps tie in what we're doing now to what people have done in the past. And it also works much better for small samples. That's the other thing, right? If you have a small sample size, you want that unbiased. The bias is biggest with small sample sizes. So if those of you who might be in special education or working with small clinical groups or however, if big data doesn't apply to you except for you're collecting a lot of data from each person you're in your study, right? REML is important. So that's one of the big holes in the world of software, really. It's a conceptual hole because there's nothing that stops us from implementing REML in theory in a package like Lavon. It just hasn't been done. Right? If you do that, you can kind of bridge together two worlds of statistics that would easily, every student in a class like this would thank you because we just stick with Lavon and not have to do anything else. So that's REML. And I say the next one is multivariate linear models using mixed model software models each dependent variable indirectly by default. At least that's what I told you. There actually is a way that you can do it directly, but then you'd have to shut off the intercept. Who likes that idea? That's that scene from like Ghostbusters where like, well, there kind of is a way we could stop this, but it's really never really done before. Right, crossing the streams and whatnot, right? It's not good, right? Oh, the first Ghostbusters, like, I don't know, before everybody was born. Okay, so next, any questions or thoughts on the quiz? No. Okay. Then I will move on. I have some good news for you, though. You want to hear some good news?
Yeah.
There is no homework 6. You're going to cry. Is that good? Everybody okay with that? I want homework to be challenging yet not insurmountable for you. I know it is. I know you try. The bad news is the next homework is a copy of this one, but it's using those mixed models. But you have until, you have 3 weeks to do it rather than 2, right? And so let me say this very clearly. I strongly encourage you to start now. We're going to use today, as a matter of fact, like it. Carpe diem, no day like today, right? This is it right now. But that's basically 2 reasons. Just as much as you're tired of me handing out assignments and fighting with my computer system, I'm really tired of it too. I'll just be honest. I need to fix it. I don't have any time to fix it. It's not like it's, at a research-intensive university, it's not like I should be spending time working on teaching. Although, I kid you not, right? So like the job performance for it, well, I could just hand out homeworks with check marks and keep my job. But no, I think, I know I'm saying that glibly, but that's unfortunately the system that we have set up here. I want to do this because I do believe in the value of it. It's just so damn frustrating, as you know. And so if I can get it to a better spot, I'm hoping that we can get there maybe in a couple years. Well, I don't know. I'd love to have a grant to fund it. I'm telling this to people in my office hours. But I'm not sure that we could get a grant easily to do that. We've tried a couple places to try it. But ironically, the only time the university cares greatly about teaching, I shouldn't say that. There are people who care greatly about teaching at the university. But they're not the majority, I feel like, right? And again, that's our focus. We should be teaching from the cutting edge of science and what we're doing in our lab, and I totally get it, right? On board with it. But the only time that it does sort of touch things is if you can get a grant to do something with teaching. And so I have an NSF grant now that's dealing with introductory statistics. So NSF will fund undergraduate statistics. Problem is we don't have an undergraduate statistics program here at the university. So I have to find a way to spin that this homework system could work with the undergraduates, and I think the next grant might be able to do that. But then all of a sudden it's like, oh, hey, yeah, we're all about teaching. Bring that money in. Let's go. 53.5% indirect costs. Let's go. You know what those are? indirect costs? Those of you who don't know, for each grant that comes into the university on certain types of budget items, which is like personnel or I think subject costs, and there's a bunch of them. It depends on the granting agency. The university has what's called indirect costs that get applied to grants, which means for the things that are cost worthy of that, my grant right now is about $300,000 over the span of 2 years total, and the university is taking something like $120,000 in indirect costs from it, right? And so when you think about why that is, now again, federally supported grants, those rates are higher. On-campus research, those rates are higher. If you have a contract, it's a different rate. There's all sorts of ways that it's not exactly that, but that's the big number that you talk about. So when you write a grant and the funding agency says, for this competition you can ask for up to $300,000, you're going to do that, but that $300,000 total cost includes your portion plus the indirect costs that go with it as well. But that's the part that the university likes to remind all of us. Our state, not just our state, but just generally higher ed, public education in this country in general, funding from state dollars has been going down over the last 30 years, and this is where some of that revenue gets replaced. So, hence the reason why if you bring in money, you could just show up to your class and you'll be fine. Right? So, point being, I'm going off on a tangent here. I'm trying. There's only so much I can do, though, and I apologize to you. I'm not trying to make that example that I am not as bad as it could be. Yes, clearly everything can get worse, but I wish I would have been able to give you more. But then it sounds like you don't want more homework right now, right? Okay. Well, if you do, okay. I was going to say someone's nodding yes. Gotcha. Okay. We're all in agreement. So you're not fretting. The other thing this is going to let me do, though, I didn't think I was going to be able to give a lecture about exploratory factor analysis and why you should never do it. And so I'm going to do that lecture now also. So we're going to have some more content that I'm going to give you. It just won't be the stuff that gets attached to homework. And I know there's less of a concern on your part whether you want to watch or not. But I'm going to film it. I'm going to record a lecture, or I might just give it in class like the last day. Okay? Yeah, Ahmed.
What about Bayesian?
Bayesian's coming. It's coming next week. Here's what I want to know. That lecture has the potential to need time in class for it. You want some time in class to do Bayes, so I just make it an in-class lecture? Is that okay? Because it's going to take some hands-on stuff. To do Bayesian next week, I'm going to ask you all to install a program. I'm going to make you install a program. I was looking at my slides today when I need to change for them. What's that?
Program or package?
A program and a package. So a lot of ways that things work in Bayes. So R doesn't have anything built in by, like in base R without a package that does Bayesian estimation. At least not that I'm aware of. And there are packages that people build by themselves to do very specific, very small problems in Bayes. And some get quite large, but generally what you see with the Bayesian estimation is that people typically, there's a handful of free software packages out there that do some general Bayesian stuff, big models and whatnot. One of those is called OpenBugs or WinBugs. One of those is called JAGS, just another Gibbs sampler. These acronyms will have bugs is Bayesian updating through Gibbs sampling. STAN is another one. It's a fairly new one. STAN is one of the names of one of the authors of one of the algorithms in Bayesian that came out like 60 years ago. So often what you'll see is that people will build an R package to take a program or a routine in R and transfer it over into one of these other packages. So basically, you're writing stuff in R. The package then goes, looks what you wrote, rewrites it in this other language, writes it to your disk, something runs. When that thing's done, it outputs in its language. R reads it, repackages it, and puts it for you to use. So R is only like the middleman, middle person, middle something in the middle of this Bayes thing. So Bayesian in class would be good then? Cool, because Bayes is a big deal. It's going to become a much bigger deal coming up here. So I think that'll do. Then I just won't plan on recording one this week. That's awesome. I can revamp. I can make it the most awesome lecture that I can. That's that's like me saying I can run the fastest marathon that I can. All right. Personal best right now. I haven't done that yet, but probably won't. Yeah, the half marathon though. Projecting off of my half marathon time would be pretty dangerous. Anyway, I'll give you my personal record lecture, my PR for Bayesian. How's that sound? Anyway, what else? Okay, so that's the good news. You got the answers to this week's quiz. I just posted next week's quiz. Quiz 10 should be available. It is. Thank you. I am, man. I'm just showing my lack of ability to do things in technology now. Let's talk now about though next week's homework, shall we? Where do we go with that? Excuse me. So what were we doing in these whole mixed models when we had multiple DVs? Should we start off? Let me grab the homework. Let me just grab the homework like you typically do. Just logging into this homework system is raising my blood pressure. I know it probably does you too because it's frustrating, but and the only person I can blame is me. Oh shoot, I didn't redo this text. I need to redo this text up here. I'll tell you what that should be after our first break. But the homework is word for word identical to where we left off the last time. I wouldn't say word for word. There were a couple typos, a couple reversals, things. I fixed those. There are probably still some more. I still don't know what's going on with question 31, so that'll still screw up. But what we're going to do here is let's grab the data right here. Show the R starter syntax. And this is tough because I'm looking at the other screen while I'm typing in front of this one. All right. So you know how this works. We open RStudio. Create a brand new blank R script file. Copy and paste the syntax in. Right there. And change the ID number. Like that. Of course, can't find it because I didn't restart it. I need to save this in my downloads directory. You know how this goes, right? You've done this before several times. I restart RStudio in that directory. Lose my mouse. Lose my mind. Okay, there we go. Read in the data. Bingo. Let's take a look at these data. First thing I did, because I like you. I really do. You may not feel that way with my homeworks, but I actually do like you. Each one of you. I stack the data for you. Okay? Because stacking the data sounds like such a... There are people like, yeah, thank you. I don't want to make this about R. I'm trying to make this about the content. If you want a challenge, what you should see, I think that's correct, is the data are the same as you had previously. I sure hope so. But if not, fine, don't worry about it. But it should be the same. So here the rating variable is listed right there. We have dependent variable. Right, so now with the stack data, we have each person occupying 2 lines because each person has 2 ratings, one for pancakes, one for crepes. This is whether or not the DV was pancake or the DV was crepe. Right? And so I also have a dummy code for pancake and crepe here listed as well, right next to that. I have a dummy coded variable saying which class the person was in, pancake class or crepe class. So you'll see for each row of person 1, they'll have the same code there, 1, 1 for pancake class. They're in pancake class the whole time. You also see experience repeated twice. And actually, this gets into kind of an interesting topic. You'll note here that pancake class and experience are kind of person-specific variables, right? As opposed to, you know, which thing they cooked, which is a DV specific, right? It's almost if what I'm hinting at here is this is a setup that we get to with multi-level models. So if you ever have data that deal with people nested in classrooms or observations nested within person, like this data right here, this is a multi-level setup, a multi-level design. We have two observations, both nested within a person, and we might want to try to partition variance so that it's variance due to people versus variance due to between people versus variance within people. And that's where the designation of whether a person-specific variable versus an observation-specific variable makes a difference. Person-specific variables explain between-person variance. That's where we're getting to. So, okay. Seem okay with the data so far? Where do we start? Uh-oh. Empty model, I like it. How do we start the empty model? Well, if you haven't already loaded the package in NLME or MultComp, please do. I have names, data here. Let me go and go back to the website. Let's grab the syntax that we had before for our multivariate models. And I'm just going to create this one, this mixed model right here for what we're doing. This is the very first empty model we did before. I'm just going to copy that syntax as a base. So once again, where I grabbed that from was from the mixed models section of the course, April 10th, today, hooray. And that is the R syntax that comes from the online lecture for that section right there. Okay, it's awfully quiet in here. You must be like really anticipating what's coming. You know it's going to be terrible, right? Is that it? What's that? Kind of. It's okay. You can do this. Okay. So we're going to use the GLS function, and we're going to call this Model 01. GLS is a very broad general function. We're going to keep the options the same here, except for data is going to change to data 01 because it's already in long format. What I do need to know is the name of my ID variable, and I'm calling that person ID. So wherever we have this ID variable right here, we're going to change this to person ID. RStudio has a little bit of a... Sometimes when I click on the last line shown, it won't let my cursor go there. I'm going to do that. The DV can stay DV again. I have that the same. But now we got to worry about what to put for the model. So what do we put for the model? What's the dependent variable in our analysis? We only allow one. What is it?
Crate.
Not crate? What are we going to predict? Rating here, right? So we're going to predict the generic rating right there. And if you give me a moment, since I have two screens, I'm going to sneak over to this other screen because I want to confirm the way I want you to code this in R. Oh, you're not supposed to see that. Look, I just showed you the answer. No, I wouldn't say that's the case. There's the answer again. Here, what we're going to do, we are going to have to pick now. Okay, so if we ran this analysis, let's just go through what this is doing right now, real quick. I'm just not going to put any predictors in. Right? We're just going to have this one long dependent variable. Sound good? No? Your opinion, I appreciate it. So I run this analysis. Model 01 shows up. Oh, no, I want to do the summary. And this is what we get on in the output right here. Now all of a sudden we have all this, dude, where's my output, right? Right? We have a bunch of coefficients. We have something that talks about correlation, something that talks about variances, or parameter estimates in this case, variance function they call it. And then we have down here under coefficients an intercept. That intercept represents what?
Average outcome for everybody.
The average outcome averaged together for pancake ratings and crepe ratings. So what we did was we took our outcome, we stacked it into one very long column vector of data. And that average outcome, so because this is an empty model, what this is going to tell us, the fixed effect for the intercept is the mean, right? That should be the mean outcome that we end up getting. And sure enough, you know this is not going to work, right, if I actually show you. This has just been my day. Nope, I want data here, pardon me. My mean, yeah, of course it didn't work. 6.20 versus 6.82. Yeah, but it's close to the mean. It's not the mean here, but it is the mean. It's supposed to be the mean, the overall average. Of course it didn't work. I'm not sure why it didn't work. Think about that. Anyway, this is not a good model because what we have is we have two dependent variables, but this software does not know how to handle two dependent variables. So the only option we have to trick it into doing something with two dependent variables is to put in a variable, a predictor, that effectively codes which variable is which. So now we can use one of those, grab the data again over here. Bless you. Here, you note I have a pancake and I have a crepe dummy code. One of those would do it. All right? Dummy coded variables allow us to go and basically we set a reference group. The thing that's a 0 is the reference group. This is no longer a group anymore. This is now a reference variable, right? Because everywhere we see a 0 for one of these things, it's the same person. They're not in a different group. That's just a different dependent variable we're describing. So this is a way of hacking our linear model software to do a multivariate model. I like the words hacking. It sounds like that's much better than fighting with or other synonyms I'm thinking of right now. But this rating, we have to pick a reference variable. And so that means we have to put in to this analysis either the pancake one or the crepe one. And because I'm going to foreshadow what's coming in homework so you can come back to this as a nice reference of where to go. Because that's why I drag this out, take my time so you see where I'm going with it as well. We're going to put in crepe. Crepe, this predictor makes pancake the reference variable. So watch what happens when I put that in as a dependent variable. Right, just add it to our linear model line. This is just like the LM function that we started class with in that regard. When we run this analysis now, we get the following values. So now things change, and some of the things change quite a bit. We get different estimates of our correlation. I didn't even look at the variance-covariance matrix before. Same thing with our variance function. And now take a look at the intercept. The intercept is 6.93. Now, to interpret the intercept, we use the same linear module logic that we've learned all class. It's the predicted value when all the predictors are equal to 0. So what is our predictor in this model? It's the crepe indicator. What does it mean for crepe to be equal to 0? Whenever crepe is 0, that means that number in rating is a pancake rating. Right? And so because of that, when we look at this output, this represents the mean of all the pancakes. For me, it's 6.937. It's the mean pancake rating. Pretty cool, huh? Sort of? So what does this beta weight for crepe represent? That's right, the difference in means for the rating for pancake versus the rating for crepe. So here what this is telling us is that crepes, on average, have a mean rating that's 1.46 points lower than pancakes. And that's the catch, right? Instead of in Levon, where we looked at the output, we saw the intercepts, they were just the straight mean. When we code it this way in the software, we don't get the straight mean anymore. We now get very specific mean for the reference variable and then mean difference. But we could still go back and put them together to see what that happens to be, right? If we wanted the mean for crepes, we could do that. In fact, we could use our GLHT function to be able to see that. Right? The mean for crepes is the sum, right? It's what is a crepe? What is the mean for crepes going to be? Well, it's if I plug a 1 in for the crepe variable, and I have the intercept there, it's the predicted value it's going to give me, and that would be the sum of these two betas right here, right? Or 5 point whatever. How we doing? Seem weird? You want to have your mind blown a little bit, again, off topic? I'm going to change that 1 to a 0 and see what happens. I'm now turning off the intercept. It ran. What? Uh-oh. Didn't run very well, though. Nope. Actually, what I need to do is this. Now look what I did. I put in a pancake predictor. I turned off the intercept. And sure enough, I got the mean back for both of them. Is that not crazy or what? Why is that the case? Yeah, Alan.
So in the previous one, the crepe or the intercept is that crepe?
That's right, yeah. And so if I show you, not the one I screwed up, but this one right here, when I just put crepe in and I leave the intercept, it's the intercept represents the value where that crepe variable is equal to 0. So therefore, that means it is 6.93, the mean of the pancakes. Crepe is now the difference in means. Down here, I actually get the direct result back again. Those dummy-coded variables actually function as intercepts for the analysis. Now, I'm not teaching you that way because it becomes even more... There's no easy way to get through either side. So I'm going to show you the interaction version first. There's probably a way you could do this with intercepts as well, without intercepts as well. But here's the question I want to know. Would like you to think about just a moment. Is if I put so to turn off the intercept of a model like this, you change the 1 to a 0, right? If I just change that back to a 1, is this going to run? If I do it, I probably shouldn't today. I'm just uh-oh. Why is that not going to work? That's right. We have the intercept. You remember that in the data, in the matrix algebra lecture, intercept's a big column of 1s. Well, the crepe variable, for half of our data, it's a 0, and the other half a 1. And the pancake variable, it flips it. The part where crepe's a 1, pancake's a 0. The part where pancake's a 1, crepe is a 0. Meaning if we sum together pancake and crepe, we get a column of 1s, which is equivalent to the intercept. And we can't have the two columns of 1, and that means they're perfectly correlated, right? That singularity Or in this case, see, it says fit is singular. Singular means a matrix can't get inverted. This is a multicollinearity problem. Like the essence of multicollinearity. It broke, didn't work. All right? So we can only do it one way or the other. Questions so far? Not fun, huh? Super fun? Ryan.
What are pancake class and grape class?
They are still predictors.
So,
We're still going to need to use them as predictors. So let's go back. What's that? So pancake and crepe represent which rating it is. Pancake class and crepe class represent which class the person was in. You can be in the pancake class, but you still have two ratings, pancake and crepe. Other questions? This is the sort of the pivotal part of where we're going to start going off the deep end. I hear laughter. Is that because where I said where we're going to start? Is that? Here, let's do this. Let me go back to the model where I had crepe as the predictor here. Again, you see the mean for pancake of 6.93. Crepe is the value. Again, what we can do is now we can use the GLHT function to go and give us the means back. Can I show you how to do that real quick? Just kind of parse through this real quick. Remember in GLHT, we have this right here. I'm going to call this the first one beta 0 pancake rating. And we'll call this beta 0 crepe rating. The nice thing about GLHT is you can name your variables whatever you like. I don't think it truncates them until very long. But here, remember, GLHT is the, you need to create this matrix syntax with a bunch of zeros and ones in the middle of it. And then one of those, you needed an entry in the matrix for each dependent variable you had, or each beta that you had. Pardon me. In this analysis, we have two betas, so we need two zeros in that matrix function. Now with that, I have been finding, well, let's just go a step forward here. Here, to get we can build these together with effects. Now this is the thing that drives me nuts about GLHT. I found this today in one of your homeworks from a while ago when I was looking up a solution. When you do GLHT one effect at a time, like one value at a time, the p-values look to be right about where they should be. I saw today a result that I knew was happening just from my own code, where the p-value was 10 times the size it should have been when you combined them. And it was the same standard error, the same t-test statistic, same degrees of freedom. P-value was way off. And I even double-checked it by figuring out the area under the t-curves using the PT function, probability of the t function, and nope, wasn't working. So I'm going to ask that you have to do the GLHT function for each one of these separately to make sure you get the right p-values to be able to determine what's significant or not. So here I'm going to call this model 01. The lin-FCT is that. This chi-square test we're going to get back to. There's one case where we need to put them all together, and that's a simultaneous test of each of the betas. But here, what this is going to tell me is the pancake rating. The pancake rating is what we knew it to be. This is the intercept of the model, 6.93. The crepe rating then is, I'll just put the summary statistic right below the GLHT. Right here, the crepe rating is given by this. Right? So what we did with GLHT, remember, each one of these ones multiplies the beta that it corresponds to in order of output. and they sum together the result. It's an inner product of these two vectors. And so this is literally the sum of beta 0 plus beta 1, or 5.47, and we have our standard error right there too. Conspicuously absent from this syntax and this output is anything that looks like a variance-covariance matrix, right? What's up with that? That's where you have to use the get var cov function. This is a GLS function. I actually don't think I asked you about this in the homework, so, or do I? No, I don't think I do. Yeah, maybe there's a question on it. If there is, I'm sorry. But get var cov now gives us the residual, the variance-covariance matrix right here. And this tells us that the crepe ratings are much more variable than the pancake ratings. And I can tell you why that's the case, like from my simulation, is because I created the data where there was two groups. Like the people who had training in crepes got much better than the people who didn't. And so that pumped up the variance between the two, because the people who got training in pancakes in my data did not get better at pancakes. So, questions? You think you might have a shot at the empty model? Uh-oh. No? Yes, you do. I guarantee that you do. It may not feel like it now. But, yeah, this is like the toughest part of the class. After this, though, you get over the peak. We end crashing and burning with me tearing down exploratory factor analysis. I've forbidden eigenvalues to be, no, I'm just kidding. Rotations to come into my office. You cannot bring that stuff in here. But right now, though, we're still like 4 lectures away from those good times. We're up against the break now. Do you want to take 10 minutes? Think this over, digest it a little bit. I'm going to go fix the text on the website. So I may not be available for questions yet, but we'll get through the next step of this, and then I can send you off to start working on this, okay? Okay.